mean, when I was team leader at Costain, that was the last job I had before I came across here. It was the first time I really found out about Fabric when I was there. And I had actually a couple of fascinating chats with people from Microsoft. And basically, I realized there's potential for a GIS in Fabric or on the Microsoft platform. And it just blew my mind that in the first call that I had with Microsoft, there was this woman, really intelligent, talented, as only an employee of Microsoft would be. But I just remember there was this moment in this first meeting I had where she dutifully, like obediently said, oh, and yes, we can form solutions or run Fabric for you in a way that is compatible with Esri. And it was like she was this obedient little person, from this massive organization that felt that she had to show how nicely they could play with Esri. And it just, that for me sort of set me off, because the GIS industry is dominated by Esri, and I don't see the reason why.
Absolutely.
When you have the might and power of Microsoft could be brought to bear to blow them out of the water. So that's really honestly why I want this episode, is to begin just open people's eyes more to how a powerful solution could be stood up. Rakesh Gupta from SketchMyView, it's a huge privilege to have you on Geospatial FM.
Hey, thank you so much, Robert.
All right, so as is the pattern for a lot of these episodes, I found something interesting that someone posted on LinkedIn. So you're the next cab off the rank for LinkedIn posts turning into podcast episodes. It was about how in a couple of lines of code, one might deploy Apache Sedona in Microsoft Fabric. So I'm really looking forward to getting into the details of that. But I see you have a SketchMyView polo shirt on. Can you tell us what this organization is about?
Oh, so thanks for having me on your podcast, Wilfred. SketchMyView is, a very small IT consulting company based out in the UK. However, we actually serve customers across the world. We have executed many projects, from UK to Europe to US. So it is, but we basically focus on data engineering aspects. But it is so what you can say is that full stack data engineering development. So what it means is that from CS. So now this, when I started a couple of years back, it was only SQL and all these things. Now this whole thing of data engineering came, and people were, just all doing notebooks, deployment, and all these things. And what is that? All the data engineers, they are meant to do. So they'll be developing things. But what we also do is that, we actually create infrastructures for those all data engineering work. It means creating CI/CD pipelines, data ops in terms of data engineering thing.
What is CI/CD?
The CI/CD is that continuous integration and continuous deployment. Okay, it is a software engineering life cycle for your automated development and automated deployment. How you developing your code, and you find that my code is working fine. It's not breaking the existing code, etc., etc. My unit tests, which is pretty nascent thing in data engineering world. Not many data engineers are, they are known to have the unit tests integrated for the data engineering work. But what we also do is that we actually create all those data infrastructures in Azure, predominantly in Azure. Though we do the couple of things outside Azure, but predominantly in Azure we actually do. So we create those infrastructures. We create all those, like if we're talking about Azure, then how do you create a factory, or if you're talking about Microsoft Fabric. But also we actually give the guidelines how to deploy things in a very automated way. So of course, if you go back to the pretty old way of, handling data engineering work, you write a SQL script in a SQL file. Of course, it means you just can't, if you have some duplicated code, you can't, refactor those already code, right? So we actually do all those creating infrastructure things, data ops from the data engineering perspective, and then actual data engineering work. Now we have a couple of in-house framework written. It means, let's say if you are setting up data engineering thing, you might be setting up data factory, or you might be setting up fabric, or you might be setting up things. So what we do is that we actually come with the framework of these are the best practices of a data engineering thing, and they use this framework that actually reduces your deployment, just setting up that platform itself from 6 months to probably a 1 week time, which is pretty useful. And this comes with, while talking and working with various customers, we actually work and we get into the similar work all the time. So we thought, okay, let's do one thing. We just, create some framework which makes our life easy, and and we can also reduce the time to market time for customers as well. So that's all about SketchMyView.
Yeah, great to have data engineering come up on the podcast at last. You're reminding me of a couple of data engineering influencers that I'm aware of. Zach Wilson, in the generic, data engineering sense. He worked at Airbnb, Netflix, organizations like that. And then in the specifically geospatial space, you might say that Matt Forrest, who runs Spatial Lab, is also an influencer. So I've been wanting to begin to have data engineering as a theme on the podcast. So yeah, thanks Rakesh for being the one to introduce these concepts here. Okay, so in the course of preparing for this, you mentioned that you deployed a GIS using Microsoft Synapse. Tell us about that.
Okay, so that story goes back to a couple of months back, or I would say over a year actually. I was working for a customer which is, which was part of the government of UK project itself, land and planning. And when you talk about land and plans, absolutely you have to have all those maps and everything where your particular application, etc. But also the company, they didn't have any data engineering things set up, right? They were full of full stack data software engineers, but nothing data. I was the first person who actually started their data engineering department actually, because of course the data engineering is actually getting massive, right? And everyone, they are trying to establish how we can utilize this data thing we are sitting at. And of course, AI and all these things, because if you don't have a right foundation of data, you just cannot do all the AI and all this stuff, right? So of course, now when we were discovering how to best use all those things, and I wasn't much aware about GIS and all these things. My encounter with GIS was probably 15, 20 years back. I don't remember the software actually, but I worked on different projects for various customers, but not using GIS at all. And the customer was asking about how do we make sense of these old GIS data, the WKT and these points and all these things? How do I
What does WKT mean?
Is well-known text. Okay,
yeah.
So and that's a pretty much good term in the GIS space actually. So people, they talk about WKT, and I didn't know about this WKT and the softwares that actually guys were using. And the management, I was having a conversation with the management team, and they asked me, we are storing a lot of maps data, GIS data. How do I make sense of this data? Let's say just for an example, how many the national parks or conservation space just within this region, right? I don't know how to do that, to be honest. If you give me data in plain text, I can make some sense, but this GIS data, I cannot make any sense of it because I wasn't aware at all. So my first task was identifying the solution, how to use those features. Now, the guys, I think we went with Azure Synapse Analytics at that point of time because the Fabric wasn't there at all, not in the news. Okay.
So what is Synapse?
The Synapse Analytics is a Microsoft data analytics capabilities in Azure. Okay. And it comes with everything from data orchestration to data transformation. Everything. It means you can connect source.
So it's an orchestration platform like Apache Airflow, Prefect.
Yeah, perfect. Yeah, perfect. Or another example could be Fivetran or something, or Daxter is also allows you to
Daxter.
orchestrate your data, etc., right? But the data factory is, the proprietary of Microsoft. Okay, they have pretty cool just drag and drop feature for any user. Of course, it actually saves time, but also you can automate those things as well. It means if you're talking about full data engineering life cycle, it means you can deploy, you can choose to just choose one environment to just develop your things, and then you can deploy to other subsequent environments. And this actually helps a lot because, of course, you do a lot of things on your dev environment, not knowing how to do or how to replicate things in the further environments, right? Which actually helps. So I was tasked with all those things, how to find the right tools and right solution, how to do it within the Apache with Microsoft Analytics or Azure Synapse Analytics environment. I went through a couple of tools, all those GIS tools, etc., the market, but we were looking for because we already built some solutions for them using analytics, this Synapse Analytics. And we wanted to use the same capabilities, same tools. How do we embed that particular feature within Spark environment itself, of course? And we are looking at massive data. It's not like, 10,000 rows of data, etc., but we were looking at millions and billions of data points here.
So what is Spark?
So Spark is computing environment, the data, where you can actually transform your data. You can query your data in a very clustered environment. So like,
is it distributed somehow?
Distributed environment, yeah. So distributed meaning you have different servers. Of course, if you have let's say if you have a RDBMS data like SQL Server or Oracle, it actually scales just vertically. Okay, you don't have a way to distribute your data. It means you hit the limit at some point of time and you can't scale. Of course, and when you are talking about Spark, it is a completed horizontal distributing environment, right? So you can scale as per your data load. You can start with one node and then you can add a lot of nodes which can process your big data. And that's why the big data became so much popular, because Spark and different tools were able to distribute that data for good, actually, right? So of course, if you were to use SQL Server or something similar, which is not designed for those things, but also the SQL is, having their different format. Now, if Spark and other tools, they gave us capability to, read text files or different files, and then you can grab that file and distribute your data, compute your data, and have your data, just computed. So going back to Azure Synapse Analytics, we actually experimented with a couple of other tools space, and then I stumbled upon this tool called Apache Sedona. And just by looking at the architecture at the front page of Apache Sedona, my instinct, my gut feeling was that's it. Okay, because I think that integrates with Spark environment. Now, number one, what we were looking at, it's not proprietary. And number two, I needed to find out if I can stitch it, through Spark or Azure Synapse Analytics environment. So I started, working on a couple of POCs, how to do that, etc., etc. Now, the people who actually are plain data engineers, they work with data and all these things, and they haven't worked with GIS. Handling of GIS is a little bit different than normal database or data itself, right? Now, as I mentioned before, the WKT, and you have a different format, how you can make sense of those data. And that data actually, deals with your, polygon point and all those things. And how do you make sense of those data? I mean, how do you apply the joins? How do you apply, or how do you intersect? You find a common, map or common place where you can make sense of those informations. And the other aspects, I was very, pleased with Apache Sedona was it can work within Spark SQL environment. So for me, it was like, a jackpot kind of thing. Okay, so I don't have to do anything actually, right? I just have to grab some files here and there, and I can embed Apache Sedona within Spark SQL code. And I can write the same joins, the same intersection thing, and I can make sense of my data. And that's how we started with one POC, and then it was, showcased within, the management meeting and internal review, architecture, etc., and was approved in one go. Everybody was very pleased that they didn't have to, find a pretty, massive, expensive tools, right? They don't have to do anything. Now, number one, it was open source. And we don't have to, spend any single dime on the top of it because it was embedded within, the Spark environment itself. A couple of jar files and a couple of, Python packages, and you are set to go. And my experience with that was really, really awesome.
Yeah. So there's a couple of things here. You come from a non-geospatial background. You're a data engineer. You know Python, SQL inside and out. So it was interesting to hear you as someone who knows the generic data engineering tooling to talk about the nuances of geospatial data, how it is somehow a bit different, and you need some new concepts and tools to handle it effectively. So that's interesting, I think, for validation for those from within the geospatial industry, to have someone who has all of their generic computer science skills acknowledging that there's somehow a different treatment that's needed.
Absolutely. I think I would like to add one thing here is that though I was a data engineer there, and we were trying to solve a data problem, but I was very fortunate that I got a chance to meet with a lot of GIS experts who were already, just working within that project itself. And the knowledge I gained there was, massively, it was really good to have those GIS experts explaining me what is the meaning of this point, this polygon, how can I make sense of it. And then I watched them during POC and oh my God, the SQL can do this one also. And they were really surprised. Of course, if you meet the data analyst, they're pretty savvy with SQL thing, right?
Absolutely.
And if you give them a flexibility of querying that using SQL, they were just blown away.
Yeah. Okay. So, because I have a tendency to engage in provocation and to make people in geospatial work to justify that they are a unique discipline. I like to provoke people a bit and see how much I can get away with saying, that an average data engineer or vanilla flavored data analyst with SQL could do most of what Geospatial does. So without prompting I haven't made a deal with you before this episode. You yourself have said that yes, there is something unique. So that's interesting to hear. And if I could sum up your characterization of Spark and Apache Sedona, is it that you can, after you've imported the modules, continue on as you were in Spark with SQL queries, but it just so happens that by leveraging Sedona from Spark, that you can have your SQL queries do geospatial operations?
Yeah, absolutely. Yeah, so I mean, the couple of jar files, I mean, we might screen share with all those capabilities we can show our audiences later on. But of course, I mean, it was really a massive help that only by exporting, the two jar files were required at that point of time because you didn't have any the Python packages for those. Of course, when you are using, because I was using Python Spark PySpark thing, it means I had to have those couple of Python packages. But I think I would also like to emphasize that these are not only for the GIS capable packages, but also they have the couple of visualization mapping thing or visualization stuff embedded with those packages, which is massive for anyone doing data analysis and all these things, which is pretty massive. You don't have to rely on, third-party maps or something to embed within Spark environment. Then you have those maps available within those packages that you can explore and have those plotted, and you can make sense of those, GIS capabilities then.
Okay, so in a way, Apache Sedona is a way for a regular Spark using data analyst to acquire geospatial capabilities.
Absolutely. If you know SQL, you know GIS then. I would say that.
Great. Okay, I think that's a nice sort of headline for things. So another thing to touch on is that you said you were doing this for a government agency in the UK, and you said it was about land management. So I have to mention then that the origin of geospatial or GIS as a discipline was IBM in around 1962, being contracted by the Canadian government also for land inventory and analysis
I didn't
of land.
know that.
So
That's awesome.
Yeah, and it's so interesting that you're talking about compute at scale for a nation scale kind of a problem for a government, and how you as a generic data analyst found your way into geospatial. And it's the same story back in 1962, where a generic data analyst of the time, from the data engineering, the leader in data engineering at the time, IBM. So it's interesting, fascinating that when you really need to do heavy weight processing, data engineering, what can I say? A software engineering firm is invoked that has access to all of these capacities for large-scale compute. So yeah, just wanted to highlight that how this is a pattern.
That's useful knowledge, actually. Very good. Yeah, I didn't know that.
Okay, so we've talked about how Azure was invoked, and specifically Synapse. Is there a similarity between Synapse and Fabric? And could you tell us what Fabric is?
Oh, so I think the people who know Synapse, they know Fabric. Or I would say that if you have worked within Microsoft capabilities within data space, I mean, of course, transitioning for Synapse to Fabric is pretty seamless. You see those known tools, those, of course, those notebooks and all these things, but you have same sort of environments within Fabric and Synapse. I think people say, if you have seen Synapse, you know Fabric already. Of course, I'm not getting into you need to learn the couple of things because the things are not same within Synapse and Fabric, of course. But of course, the Fabric is, I think, I mean, I started, trying Fabric probably more than a year now. I'm working and supporting customers in this space on Microsoft Fabric itself, of course. And one day I was looking at, and I think, this coming from my previous company, the previous project, when I was helping this one particular customer on GIS. Of course, my part was to build that particular solution, integrate within current environment, and of course, we set up that internal team for them so they can run the show later on. And I had to move out. Now I was analyzing this. If Fabric was there, if we have to do everything in Fabric, and I hope the customer who I helped, they are watching this show and they realize that if they haven't migrated to Fabric, it's time to migrate to Fabric then.
So is it also a orchestration platform? What are the basics of Fabric?
So Fabric, you can say end-to-end analytics. And how do I define end-to-end analytics is that you have a capability for data orchestration. you have a capability to ingest your data, transform your data, and then you can, you utilize your data. You can have analytics on your particular data then. Now the fabric, the concept is same. So the people who are coming from lake house concept, they'll find this one lake and lake house, but ultimately they are using the same delta file format. Okay, so what you are using is that lake house, and lake house inside one lake is being used by Microsoft Fabric. The one lake foundation is that, same delta format, and so
So
you
a
actually
lake
save all
house
this
is
information.
distinct from a SQL Server database.
So lake house, uh, of course, in the earlier days, we had Microsoft analysis services and similar kind of tools, proprietary tools for Microsoft. But of course, with the invention of Spark and all clustering distributed platforms, it actually allowed you to use your files. It actually may be text file, it may be CSV file, it may be some other files. Now, from data analytics perspective, that's not enough. Okay. Now, and why I'm saying is that's not enough, because if you are reading files and writing to some other files or some other location, you actually run into what happens if my files are corrupt. What happens if, that particular Spark process has managed to write at some extent, but it failed. What happens then? Then you have a data issue here. Okay, and that's why the delta file format came into the picture, and that is ACID compliant. Okay, it means it either all your transactions are committed successfully or rolled back successfully. Then it means you have a data sanity. And that's how the lake house concept actually grew, right? So initially the lake house was that you dump your files and you start building your analytics. But lake house actually goes beyond that. Okay, so the lake house means ingesting your data, which we call as a bronze layer. So you bring your raw data in bronze layer, and then you do some sanitize your data. We call it as a silver layer. So you do have a data conformed. Okay, no duplication, nothing. It means if I'm an analytics guy, or if I'm a data analyst guy, I can use that data from silver layer to build my analytics, which we call as a gold layer. So gold means analytics grade data. And of course, the Spark and Fabric capacity, like FCU, you actually, they actually call. So this actually allows you to have those, and they are integrated with those, challenges. So in the earlier days, we had Microsoft Analysis Services, pretty proprietary, Vertipack engine and all those things. I didn't know what's underneath, etc., etc. Of course, the Microsoft knew, and we had to rely on Microsoft. Okay, that's a proprietary software that is using Vertipack engine, and that's how it actually processes those analytics things, right? Now, the Lakehouse, I have full control how I want to actually process my files. Of course, the modeling remains same. Just you choose your Kimball data model or you use something else. You model your data from analytics perspective, which we call as the gold layer in the lake house, and then you use that for your analytics
I love
reporting or
this
whatever.
that you touched on this bronze, silver, and gold terminology because it's bubbled up in my own experience, from talking with people. So is the bronze the unprocessed raw data in whatever of the hundreds of different file types there are that you might get data in? You mentioned CSV,
Absolutely.
even
Absolutely.
raster, pixel files, shape files, heaven forbid, the whole lot.
Completely.
So
Audio
it's just
files, videos, everything you
the
can
whole,
actually
okay,
do.
so if you're going through a data collection exercise for a new project to build a road or whatever, and you're just, and often geospatial is used to understand the feasibility of this proposed road in the context of environmental and planning and other constraints layers. So there's a huge data collection exercise where you go to all sorts of government organizations, private organizations, buy all the data that will come in all sorts of different data sets. So that's the bronze layer, is it?
Absolutely. So bronze,
And
how do you define bronze? Is that you're your raw transactional data is your raw layer, which is a which is a bronze layer of your whole lake house thing, right?
And part
Now,
of that is that there might be errors in that data. There could be
absolutely.
duplications, there could be empty data sets, all
Yeah.
sorts of issues. So it's just whatever comes in. And then are you saying there's some sort of transformation or normalization process where you bring in the data from all these different disparate formats, you bring it through some QA/QC process and into a common database? Is that right?
Yeah, I mean, we actually say you either say layer or you say zone. So I conform that data, normalize data, and they are brought into silver zone or silver layer. That's your conformed data. There is no duplication in that data. Plus, if you have some sanity issue with your raw data, you fix that in silver layer. So your data is, I can completely trust your data. That's your whole enterprise data in silver layer then.
With you. Okay. So at the silver layer or tier or stage,
Yeah.
it is, are they still separate files, or have they been brought into a Azure blob storage or into a SQL database? Are they in one single point of truth?
Okay, so let's go back to the bronze layer a bit. So when you are ingesting your data from different sources, you might choose to bring them, like say, I want to ingest in CSV format or JSON format or Parquet or something else, right? But the data engineering team, they have different requirements and they are different use cases, to be honest, right? Now, from my experience, you probably need to stick with one file format during data ingestion in actually bronze layer. Let's say if you stick to CSV, you stick to CSV for so every data you are getting into bronze, it's CSV. After CSV, you have Delta Lake, which is the files are coming to Azure Blob Storage, or if it is AWS, then S3, right? So we are utilizing that blob storage for that, just upkeeping that all files. Now I have seen various cases where they actually ingest data in bronze layer in Delta Lake format, which is completely up to their requirement itself, right? But sometimes what happens that analysts, if they are using those files, or if you want to do something, let's say if you have a data refilling case, let's say if you want to build your silver and gold layer completely, discarding your old logic and something else, right? Now you have a space which is a bronze layer which you can utilize to build your silver and gold layer again. Okay, so not going or saying that one format is not useful. It actually depends by use case to use case completely.
So the point is that a data engineer needs to form their outputs in consultation with a data analyst or a business intelligence analyst, the people downstream who have their own processes that require some constant file format or uniformity on the output from the data engineering team.
Absolutely, absolutely.
All right, I'm only just keeping up with you, Rakesh. But yeah, I appreciate your ability to get down into the weeds here, and it gives a realistic understanding of what the nitty gritty is for a data engineer. Okay, so you've begun to talk about Fabric. We have some contrast of it with Synapse. Just on a personal level, it came up for me when I was a team leader in my last role at an engineering firm. And it piqued my interest really because there is no more constant, persistent, widespread platform than Microsoft across all corporate environments and government environments. And it sort of made me wonder really, if we are leveraging that platform enough in Geospatial, because the company and the platform or the stack that dominates Geospatial isn't Microsoft, it's Esri, but there is, a hyperscaler based, data engineering computing platform that most organizations have access to. So to me, it just looks like there's an opportunity waiting, to be seized, to have a GIS created that's somehow native to Fabric or to the Microsoft ecosystem. So that's why, with that context for what I'd sort of encountered in my own career, that's why I was interested in this LinkedIn post you made, where you literally said a couple of lines of code and you've got Apache Sedona in Fabric. So talk us through that.
This is a Fabric workspace. I'm using it. Now, the best thing I would like to highlight about Fabric is that you don't have to spend any single dime before you want to really stick with Fabric. It actually gives you a trial for a couple of months. For me, it was 2 months initially. This is how I started. And probably I was doing something crazy. They actually kept me extending every time after 60 days, right? So it is a pretty nice platform. Of course, the guys who have seen Power BI, they are pretty aware about the look and feel of Microsoft Fabric here. Now, specific, because this is not, I'm not going to go deep about Fabric and all these things. I'm going to stick with, how you can write a couple of lines of code, and then you can use Fabric to bring your that JS capability within Spark environment itself. So of course, if people are aware with Microsoft of Power BI, I'm actually using one of the workspaces I have created, which is Fabric Dev. My suggestion to, of course, when you are on this workspace, you can create a notebook and you can start integrating Apache Sedona. However, I always tell people that create your specific environment, like development product, different other environments for your use cases. And that's how I would actually recommend people to do that. Now, in this case, I have an environment here called dev, which I created, but for audience's benefit, I would like to show how they can create environments within Fabric workspace itself. Now, they just have to go new item, search environment, and choose one of these that's complete. And that's how you actually create your environment. You give your environment a name. And why that's a recommendation? Because it actually allows you to build your specific environment. Let's say you have a requirement of specific Spark configurations, or specific Python packages or specific jar files. Then you create your environment and use this environment for all the notebooks you actually plan to develop or deploy. This is the number one benefit, and that's why I just recommend people to use and stick to the environment itself. Now, going back to this one particular environment, what you can do here is, the good thing about Microsoft Fabric is that it actually comes with a lot of PyPy packages. So you have everything here, which is built-in library here. Of course, you see version. If you want to upgrade, you can do. So we can have Python, you can have Java, you can have R. I'm going to stick with Python here, but you have a lot of PyPy packages installed already. It means you don't have to worry about how do I install, installation time, etc., etc. Number two, if you want to use some PyPy public libraries, then of course you use and add your PyPy packages here. Now, in this specific Apache Sedona case, we are sticking with 2 jars files that we need. Now, I have uploaded it because it actually takes time, because how it works is that if anyone has used Spark before, and if you want to register something, then of course it takes a little bit of time to install and then initialize within that Spark environment. And that's what it actually does, right? So what I have done, I have installed a couple of jar packages, which is required for Apache Sedona, and then publish it. Once you have published, then what it does is it does 2 things. It actually installs the jar packages within that Spark environment, and then it configures Spark to use those jar files already when you are using your notebooks. And that's the main benefit of using custom libraries here.
So do you install those custom libraries from this page or from somewhere else? Or you drag and drop them on?
Yeah, so you have upload and download
upload
options.
there. Okay.
Yeah,
Yep.
so if you click on upload, then you choose from where
Yep.
you want to upload, and then you upload here.
Okay.
And then
I'm guessing you go to the Apache Sedona website to download those jar files.
Yeah, I have gone to Apache Sedona. I mean, the documentation will lead you to a couple of other links where you can use your jar files.
Gotcha.
Okay, and it will be specific. In this case, I'm using 150 and here 150. For, of course, the Apache Sedona has got different other versions now beyond 1.5. It means if you want to use specific Sedona version, then you have to use that that version specific jar files. Then that's a prerequisite of here.
Cool.
Now, once you have done that, once you have uploaded files, it is going to show you option to publish, and publish means it is uploading those files and registering within the Spark environment. So those libraries are available within your notebooks. Okay. Now I have got two notebooks available here. One is Apache Sedona integration. The images, I have copied it from. I like this architecture, to be honest. I'm an architecture guy. If you show me image, I can instantly just I can mix all the sense of it, what you are doing, etc., etc.
Even for beginners like me, an image helps.
Absolutely. I mean, of course, when you are running a POC, it actually helps what it is doing under the hood, right? I don't know. So when I was doing this stuff, I was kind of, doing a solution architecture stuff. So how do we integrate within this specific environment? And it actually helped me a lot understand, okay, this is what it actually does, right? And I can actually make sense of everything here.
I can see Scala there. Is that how you pronounce it?
Yeah, Scala, yeah.
Yeah, so I just wanted to flag that because Zach Wilson, in his efforts as a data engineering influencer, he mentioned that Scala might be just as important as learning Python.
Absolutely, absolutely. I think so my transition to data engineering world is a typical software engineer. So so sometimes many years back I have done Java related programming, then .NET and all these things. But of course, the people are using Python and Scala. It depends. But I would say Scala is also important. Scala is also important if you are really writing some mission critical things. Now, with the introduction of Spark, all those data frame APIs and everything, of course, it is absolutely right to use Python for all those things. But of course, if you want to get to that low level thing, then Scala is your friend. Okay. Now, you need a couple of PyPy packages so that you can write GIS SQL queries within Spark environment, what actually Fabric is using here. And a little bit of environment here, I am using this PySpark thing. And if you see, I have chosen this environment dev where I have installed my jar packages, which actually got registered within this Spark environment itself. And it is pretty important to do. And for audiences, if you run into Apache Sedona libraries issue, you should be checking first what environments you have set up here, first of all, okay? And if your environment is not where you have uploaded your jar files, then you need to set that here, okay? So here I've set the dev. I have installed a couple of PyPy Apache Sedona 150 in this constant and a couple of other Py packages, which is important to run those queries here. Now, I'm not getting into what these libraries are. Of course, you have to use those other libraries. Now, when I posted the link about just 2 lines of code, exactly 2 lines of code here. So discounting from this statement, just if you use from Sedona Spark, and what you are doing is that you are utilizing Spark environment to create a context That's all you are doing here. So what you are doing here is that I am using those PyPy packages I have installed, Apache Sedona in this case, within Spark environment. And then what I'm using is that Sedona equals the Sedona context dot create Spark. That's all. And that got registered with your Spark environment. And if you see, I am now writing this GIS capable SQL queries now in pretty simple example and very specific, like st underscore. It is syntax driven, but it actually what it does is that geom from txt. What it is doing is that I am supplying this txt, which is a polygon here, and it is converting into geometry data type here, which is pretty cool. Now, if you have a simple Spark, you didn't have that capability, but these 2 lines of code, you have now capability of using this GIS code, which is pretty amazing, right? You didn't have to reinvent any tool, any expensive tools, etc., etc. You just used Apache Sedona within Spark context, and then here you go, okay? And you can do a lot of those things. If you're writing, of course, ultimately the output for these kind of applications are GeoJSON. Okay, so you actually export that data to GeoJSON format, and people can use those data to drive and show these things on the map itself, which is pretty.
Yeah, this is amazing. So basically, you're saying is it cell number 6 there? That syntax creates a polygon.
Absolutely. Yeah.
Cool.
Yeah. So that's a geometry data, and this is just a polygon, and it is what it is doing, that it is giving me geometry data type, which is useful for this GIS.
So there's a bit of syntax that says as geom that creates a record in blob storage somewhere that stores that as actual geom data type, not just a regular text row in a table.
So it's not saving to any data lake at the minute. What it is doing is that it is just displaying what's we can struct really Spark specific data type declaration thing. And what it is showing you up is that, oh, this is a struct type. So this is one of the data type I'm actually going to create, which is geometry. And for the audience's benefit, geometry data type is supported in data lake. Okay, and that is pretty useful. Not many people are aware, but geometry data type is supported by Lakehouse or Delta file format. They are supported.
From what I understand, there's also geography. There's 2 sort of GIS related data types, geometry and geography. So you've mentioned the geometry one. Yep.
So this is a little bit of code, and there's a little bit of actually things what actually we can do. So we have 2 cities and we have 2 regions. The idea was, how do we, see, or how do we find that out of this city reasons, and how to plot everything within the GIS environment itself. Pretty straight example, the city array and region array. This is Spark specific code. We are creating data frames, create or replace view. Just understand this as a table in Spark. So you have cities row and region row here. Next step, what we are doing is we are registering those geometries here. So what we are doing, we are creating as a cities row. So geom, we are just, so these are geometry here. And then final step, pretty useful for any data analyst or data engineer, is that how to perform a spatial join here, which is, a magic Apache Sedona is doing here. You didn't have Spark capability before this packages. You cannot play around spatial data. Now you have a capability where what you are saying is that I have 2 data and I want to find or apply some spatial join here and see what is the data here. So now
by spatial join, you mean, for example, which city is in which region?
Yeah, absolutely. Yeah. And that's what I mean. You didn't have any means of having those informations within normal Spark environment. So by writing a couple of 2 lines of code, you just have those capability within this Fabric environment now.
And I love this, it's handled without any graphics or any mouse clicking, anything, any, what can I say, Esri ArcGIS Pro toolboxes.
Absolutely.
It's very succinct, and you get just a 3-row table showing is it that cities A and B are in region 1.
Yeah, I think this is pretty important. Many of the use cases I've come across, we meant to send those data within GeoJSON file. Okay, no map, nothing. Just send me that data in GeoJSON, and I can make sense of, because that's a standard within that GIS, world itself. Send me that GeoJSON file, and I can do how I please. Now, for audience's benefit, what this means from a diagram perspective, and of course, I've used a couple of other things, but this is what it is actually depicting. City A and city B, they fall under region 1, and city here, the different city is under region, a different region.
Amazing. So you can draw maps as well, as it were.
Yeah. So you have capability of draw the maps as well here. So within Spark environment, if you can have a spatial join, plus you can use those visualization also to gauge those data, which is pretty powerful, to be honest. I mean, as you saw, just 2 lines of code, and you actually converted your normal Spark environment to GIS capable Spark environment. Pretty easy.
Amazing. So a couple of terms that stood out there for me was Sedona context, or just the bit of syntax context. It might be worth unpacking what that means. And then also the concept of a data frame. Are you able to give us a few sentences about those two?
Okay, so what the Sedona context is doing, it is just registering those, in a very layman term, I would say this actually allows all the functionalities or functions we see, like stgeom text or other SQL specific functions, it makes available within that Spark environment. That's all, nothing else.
Easy. Yep. And what is data frame?
So data frame is, you actually understand the data. For any user, I actually describe data frame as a row and column information. So your data is in row and your attributes like columns. So the data frame is a bundle, is a pack, how you see your data. If you have to see, or if you have to visualize, then consider this as a row and column data thing. So that's a data frame in the Spark context.
Got you. So am I retrieving data from a database or something in the lakehouse and bringing it into the data frame, and then subsequently doing operations on the contents of that data frame?
Okay, so how the data frame works is that it is not anywhere in the database at all at this minute. So let's take an example of reading data from a lakehouse. Once a Spark runs this query, of course, it reads that data from lakehouse, but it actually understands that the data frame is that it is in process. Understand this as an in process data frame, and it can use that data frame to drive all other queries. Now, Spark has other flexibility, like if your data frame is just in process thing, and if you have to use your data frame again and again, the Spark or the different other companies, they have different recommendation. Ideally you'd cache your data frame so it can be utilized on and on. So your query time is pretty performant in that way. Of course, this is
so it's not in memory then.
It is, yeah. When I say it is in memory, then of course it is in process in memory at the minute. At the minute it is in memory. So it is utilizing those nodes memory to keep that data there. It's not in the database at the minute. It just hasn't saved anywhere. It is just there when you are executing that code. It is in memory there.
Yeah.
And then if you want to utilize that data, if you want to write that query, then of course Now, the couple of syntaxes here where we have created a view. So here I am creating a view. So that's a data frame. Okay. And then in the next frame, what I'm saying here is that CT raw, consider if you are from database background, then consider this as a table name. And what I'm doing here is what I'm saying is that my data, I'm actually converting my data frame to a table which SQL can understand then, which table I want to join.
Yeah. So here's a question then. If a data frame is in memory, if I'm understanding things correctly, then what if you have an absolutely massive data set that's larger than memory?
Of course, you just run into different other issues, right? There are different ways to tackle this issue. Now, the good thing about the distributed database is that, of course, it can scale, of course, so it doesn't run out of memory. Okay. There are two parts of this distributed system. One is that which is executing or which is giving instructions to all other nodes what to do. And when all the nodes, they have all the information, they send back to this executor in the Spark context. An executor have this information passed to that kind of reading program or consumer program. There might be cases when executor is running out of memory, then of course you just scale it. That's all you do.
Okay, so the data frame contents is in a way a reference to potentially a massive distributed data set across many, what can I say, across a cluster of machines.
Yes, but the only difference is that the executor will have the last process data, means what I'm after, right? So if I'm writing select star from one particular table and that, the data within that lakehouse itself, so first stage, it reads that data, it loads into those nodes for those processing, and then it brings back data to that executor. Okay.
Okay.
So, and that executor is only interested in the output results.
Okay, and the output
But
comes back in the data frame?
yeah, and it actually comes back in the data frame. But data frame, as again, it is in process. It's
Okay.
not in the database yet.
I really appreciate your patience as I ask you the most painfully
No,
basic questions, but
no, that's fine. That's okay.
all right, cool. So we've got in front of us a demonstration of how simple it is to set up Apache Sedona in Fabric. This is amazing to have this tutorial. So bluntly, why is it worth it to do this?
Okay. Why is it worth? Because of course it doesn't require any third-party tool. And if your data platform or data engineering code is within Spark environment, then the Sedona is quite useful in that context. The number one, it runs within that Spark environment. We don't have to use third-party tool. And if you are using Fabric, then of course you don't have to do any other setups, etc. You would normally do with Spark configurations. So it has massive benefits. Now, in terms of cost also, since you are not having any third-party tool, of course, your management people are happy. I don't have to spend a single dime. So that's one. The second thing, the data engineers, they don't need to they don't need to learn a different tool altogether. Of course, I'm discounting that GIS knowledge, assuming that a GIS terminology like what is just geom, WKT, polygon, etc. Then if I'm a normal data engineer who actually writes SQL, all then I can have the same SQL. Then I can have the same SQL for those all JS capabilities, which
Yeah,
is pretty useful. You don't have to leave your current environment, learn
yeah,
third-party tool, and do something, stitches, sketchy, and all those, things. You are not doing it. What you are doing here is that SQL, and you have just to do SQL. That's all you are doing here, nothing else.
yeah. fantastic. There was a small question that I forgot to ask you when you're going through the demo of relating to your screen share here. So do you set a coordinate system somewhere when you are registering this spatial data?
Oh, well, I'm not registering any coordinates. It is just point in terms of that GIS thing. So you can consider that these are the coordinates which actually, GIS understands. So this is a point.
Okay. So, this is not in a projected coordinate system where you're using eastings and northings or meters. Could you do that if the data was in, for example, in the British context, in British National Grid?
I think you can do that. I mean, I think you can do that. Easting, northing, you can do that. But I mean, I haven't done it before. But I think you can do it. To be honest.
Okay, yeah, that kind of thing would be quite important for GIS analysts to be able to take account of. And
I'm sure
that is a huge problem in the industry, is how to deal with all these transformations.
Absolutely, I completely agree, and I'm pretty sure that the Sedona team, they have taken care of those things as well. I'm pretty sure about that.
Cool. Okay. All right. So I'm convinced that it's worth it. So yeah, thanks for that demo, Rakesh. So another recent development in the Sedona and spatial world is SedonaDB. Could you tell us about it?
Okay. So when I was, from my experience, and why it is useful, because from my experience, when I was setting up Apache Sedona within Spark environment first, I didn't know what to do. Okay. I had to scout through the documentation, how it works. Of course, for me, writing those 2 lines here, that's completely okay, but I didn't know that, right? I didn't have much experience. I know how to even run those, polygons or spatial, queries within Spark environment. And of course, the Sedona is for distributed computing environment. Okay, so if you have many millions of data points that you can utilize, then you use your distributed Spark cluster. Now, I want to give a real, why DuckDB is popular today, because, just pip install and then you start using DuckDB. Now, DuckDB is quite useful for GIS. It has got a couple of GIS capabilities also. Now, why DuckDB is quite popular these days, because of course, just pip install and you're ready to go. And that's how I see SedonaDB. So I know Python, and I just have to do, PyPy, this whole SedonaDB. And this SedonaDB is not for a distributed environment. This is for a single node. Okay. So it means if you are, doing something pretty small or POC or something, but I still see a use case where if you have pretty small data sets, then of course you can utilize SedonaDB. Now, and that's how I define it. If I would have SedonaDB at that point of time when I started to run my POC, I would have gone to SedonaDB to experiment, and within 5 minutes I could have done things which I actually took time with Apache Sedona integration at that point of time.
Okay, so does it run from a browser? Because I mean, the first thing that sort of springs to mind, at least for a GIS person, is, well, what about PostGIS if you're running QGIS or Postgres? There's spatial capabilities with spatial SQL. Oh, sorry, with SQL Server, you can do spatial SQL in that. Oracle, you can do spatial operations in Oracle databases. So, why should I care about SedonaDB when I have all these other ones?
Yeah, I think from my experience, how I would define is that the Oracle and all other RDBMS packages, they have these JS capabilities, but they are not truly meant for GIS.
Okay, they're not GIS first or spatial first, not designed for that.
Not designed for those use cases. Now, SedonaDB is, It is designed for those GIS use cases. Okay, and they were developed. Of course, I think my experience, number one, they were developed keeping in view the GIS as a first-class citizen. So that was the fundamental. Second, if I'm starting with Sedona, where do I go, right? If I have a very small use case or I have a very small data set, I don't see a use case for Apache Sedona within Spark environment. So I can use just SedonaDB, a one node thing. I can host it. I can utilize that same SQL queries, same syntaxes I can actually utilize there. And I don't care about Spark and all these things, which is pretty useful. Maybe it is for POC or maybe I have a very small data set, but pretty heavy, pretty useful. And as I said, all of the databases, the GIS was an integration, not foundation for those databases. Now this SedonaDB, the foundation is GIS data, nothing else. Okay, which is pretty useful.
So I like the fact that you said for creating a proof of concept, we've got a small data set and you want to basically play around and prove something before you go to the time expense of setting up. As easy as you made it look, nevertheless,
Absolutely.
There's some things you need to do to set up a Sedona or to add Apache Sedona capability to your Spark environment. So you're saying the same sort of syntax. Once you get something working in SedonaDB, you can bring that syntax across to your Sedona environment in Fabric.
Absolutely, you can do it. Yeah. So, the Apache Sedona, of course, if you don't want to use Fabric, I love Fabric because I don't have to be lost with all those configurational stuff on my laptop, Spark configuration, etc., etc. Spark environment is already there running, and it actually allows me to reduce my time to market, right? I can experiment quickly, okay? And I don't have to worry about all those Spark nitty-gritty underneath, which is pretty useful. Of course, on-prem solutions, or if you don't want to use Fabric, that's completely fine. Now, I would actually took an opportunity to highlight this feature within MS Fabric environment is that MS Fabric has got this capability where you have a dedicated Python environment. I just haven't seen many tools offering that, to be honest. Okay. I mean, if you talk about any other, the data companies, either they are using Spark or clustering or distribution or distributed environment. But of course, let's say if you are a data science or analyst, if you want to not get into Spark and all these things, all you know is a little bit of Python and SQL, you have a dedicated Python environment. And what this means is that I don't have to worry about Spark at all here. And just even if I know SQL, I know a little bit of Python, I can use that one single node to build a very powerful proof of concept or data exploration queries. For audience's benefit, I have created this SedonaDB demo, and if you see this, I'm using this Python environment here, which is using version 3.11. Okay, and what this means is that it is using a 16 gig, one single node here. That's all, and 16 gig is pretty powerful, to be honest. Till this day, it is powerful. Okay, I can do a lot of things just using the single node 16 gig.
16 gig of RAM.
Yeah, 16 gig of RAM, which is good. I can use it for data exploration purposes. If I have a very small application, I can utilize this.
So this is from your local machine?
No, that's the MS Fabric environment here.
Okay. Yep.
So
the virtual machine has 16 gig. Okay.
It is just using this, MS Fabric virtual machine somewhere. It is hidden by the user itself. Okay. I don't have to worry about that infrastructure. It is there. Okay. And this is pretty powerful actually. So if I I think if you go through the documentation, what Microsoft Fabric team they have written about, and I think they're quite right. This is, boom. This is boom for data engineers or data scientists who are looking to explore their data. Okay. Now, if you are a data engineer or data scientist, your initial days are like exploration of your data. Okay. What is this data actually? I want to understand this data. I'm not worrying about data engineering, lakehouse, nothing. What is this data actually? And I want to understand this data. I want to explore this data. And this actually gives you a very powerful tool to use one node 16 gig memory node you can actually utilize. Now, if you see this, I've just copied this from SedonaDB architecture, which is self-explanatory itself here, which actually comes with spatial indexing, statistics, and all these things. And I don't have to worry about registering within Spark environment because there is no Spark here, just Python code. Okay. And if you have Python installed locally or here in Microsoft Fabric environment, all you do is pip install Apache Sedona DB. That's all. I installed it like, anything, and I can utilize the same queries here. And I can
that's
use
similar to DuckDB. So you can basically just invoke it from a pip install. Fantastic.
Absolutely. Absolutely. And this, I think if the audiences, they go through the SedonaDB website, they have got a lot of other tools to check your statistics, performance, etc., etc.
I don't mean to fixate on coordinate reference systems, but I know from hacking around in DuckDB that can be an issue. So yeah, I expect one of the things with SedonaDB, if spatial data is a first-class citizen, that there will be far less issues, put it that way, dealing with projections.
True. Agree. I think the DuckDB is, of course, we go back to that same statement. DuckDB is not designed for GIS works, okay? But SedonaDB is designed for GIS works itself. My reference to DuckDB was it is as easy as DuckDB as, the DuckDB is, of course. You just use pip install and you're ready to go. And that's what, I'm referring to because when I stumbled upon Sedona at that point of time, that there wasn't any SedonaDB. So I had to go through documentation. I had to go through the jar files, how to do those, how to register those things. Of course, it looks like two lines of code, but finding those what to do was time consuming. And I wish I had this tool, this SedonaDB at that point of time, and it was so easy for POCs and all those things. And as I said, it is just easy as pip install, and you just import that SedonaDB. You just connect to SedonaDB and you start using your SQL query as you would in Apache Sedona. Then same thing, which is pretty massive and useful. In this case, I've used ST interacts. It means it is finding a common, point a common point within that particular region, which is pretty useful. Of course, when we were in elementary or secondary school, we talk about all those intersections, unions, and minus. Of course, the SQL guys, they actually know it, intersection, union, and all those things. But the capability of applying those logics within GIS is massive.
Yeah. Yeah, you're taking me back to my spatial databases training under Matt Duckham, a fantastic British professor at the University of Melbourne. Yeah, that was part of my GIS masters. Okay, so you've got a table there with two geometry columns, one for cities, is it? And
yes. Yeah, one for cities and one for these countries.
Step us through what's happening.
So what I have done, of course, first one, you connect to SedonaDB. This is just an example which we did earlier with Apache Sedona. What it is doing is that I found this program from SedonaDB website, which is pretty useful, to be honest, because my experience with Apache Sedona, of course, Apache Sedona, they have improved their documentation a lot. In last couple of months and last 1 year, they have improved their documentation. When I was doing that, you didn't have much documentation around what to start, how to write, how to start, right? And this is, this what I have copied it from directly from the SedonaDB website. And what it does is that you don't have to, run around what data points I need to look at. They have got you covered. So they have got a list of cities. It means they are the cities here.
So what's happening there is you're retrieving a Parquet file on the internet and bringing it into your SedonaDB database.
Yes.
That's really, it's amazing. I love how you can just do that in a couple of lines of code.
Absolutely.
One notebook cell. It's great.
Absolutely.
Because it's a hell just to go and collect data and download it all, and oh my god.
Absolutely.
Doing it with the keyboard here is amazing.
Yeah, true. And the next step, countries. These are the countries, and what I'm doing is, of course, converting to views so I can query through SQL. And what I'm doing is that joining, of course, what I'm joining is basically this geometry data, nothing else. And the geometry data gives you what is the intersection here. Okay, join the cities and countries table, and then what I'm using is that what is the common intersection here.
So you've got the cities then, and the name of the country and continent per city as the result of that intersect.
Yes, and that geometry thing. Yes, and if you have a map capability, then you can utilize this data, and then you can have the visual representation.
Does SedonaDB come with the ability to put in a notebook cell a map?
You can, I think. I'm not sure, to be honest. I don't want to say it doesn't come with that, but I think the previous pip install with Sedona, if you can install PyDeck and all this for your visualization stuff, and you can embed this data into that particular.
So you could import another library to then show in a notebook cell the results of that intersect. Okay, nice.
Absolutely. I think the great thing about the Python packages is that everything you want is available somewhere. You just have to be aware. You bring those here and then you use it.
Okay. All right. Well, yeah. Rakesh, you've made all of these concepts a lot more accessible, and freely making available your time for this tutorial via Geospatial FM. It's a real privilege, and I especially appreciate your patience dealing with my basic questions.
Yeah, I mean, I'm my experience with GIS, and I have had the same kind of tolerance from different GIS experts, because I didn't know what is this polygon and point you're talking about. I don't know. Explain it to me, please.
There are so many weird and wacky concepts in Geospatial. We haven't even gotten into network data sets and upstream and downstream traces and how complex that can be. I maintain this stock index of all geospatial companies worldwide, and I've segmented it into 28 verticals at last count, and there's a good amount, more than 10, of just network modeling companies where their whole business is mapping the millions of lines that are a telecoms network or a gas distribution network. So just to say, there's incredible complexity in how to really model the world that we have to grapple with. So really all the help we can get, and this is an example of how really we need to lean on and leverage the power of data engineering, computer science more broadly. And I think you're an example of what you guys from your side can bring to the table and make what we're trying to do a lot easier.
That's good. Yeah, I think these tools are giving platform to many ideas, to be honest. I see this, the many startups and companies, they are looking to explore their GIS data, but they didn't have, necessary tools available. And I think this actually now gives you a little bit of, capability to the developers and companies to explore those tools and have them integrated just without spending loads of money or proprietary software.
Yeah, I would say there we go. Yeah, so I feel like there's some benefit to the collaboration from both sides. I think, there's a bit of demystification that you've done, perhaps for developers and data engineers that haven't ventured into the dark and mysterious world
Yeah,
of spatial
absolutely.
data. But you're also signaling how it is easier than maybe a lot of generic geospatial analysts have thought. It is easier than expected to begin to go into the world of a computer science first approach. And your simple demonstrations there, I think provide a lot of encouragement to those who otherwise might be bamboozled and just carry on with the mouse in ArcGIS Pro.
Yeah, true. Absolutely. Yeah.
Cool. So yeah, any final words, Rakesh, about SketchMyView or your own work or next challenges?
No, I think I'm not going to talk about SketchMyView, of course. I mean, what I would like to say is that thank you for finding that post and found it valuable. In my experience, not many people are aware that capability, do exist within Fabric or Spark environment itself. Now, with advent of SedonaDB, you don't have to deal with Spark at all for your initial POC, things.
Yeah.
If you have just a laptop and a Python code, you are ready to go. But if you have Fabric, even better, you have a dedicated 16 gig RAM node available for your disposal, just to go and explore these things, and it is very valuable for any team or any company.
Yeah, and I think it's important to highlight again that incredible high capacity compute for geospatial problems is available in Microsoft Fabric via Sedona without having to pay Esri to grapple with this gorilla in the room in geospatial.
Absolutely.
I think that is therefore some progress toward what came up for me when I was this team leader at this engineering consultancy in the UK before, where I was wondering, why on earth is Microsoft having to play nicely with Esri? Why isn't there leadership from them in geospatial? So I think you have taken us a bit further along in understanding how people who have the most popular platform at their disposal, Microsoft, can do probably all they need to, without having to pay the Esri tax. So yeah, thanks for showing us the way, Rakesh.
My pleasure. Thank you so much, Wolf. Thanks for your time today.